Okay, so now let's talk about electronegativity. All right, so remember, electronegativity is the attraction that an atom in a molecule has for the electrons of a neighbor. Okay, so how greedy is that atom for electrons from its neighbor? All right, and in general, that increases, that greediness or that electronegativity increases with increasing effective nuclear charge. Okay, and so let's go ahead and write down effective nuclear charge and remind ourselves that that increases as we go across a period. Okay, so with increasing effective nuclear charge, then we have increasing electronegativity. All right. Also remember that as we go down a group, then the orbitals are getting larger. The electrons are on average farther away from the nucleus, and so that attraction decreases. So electronegativity is going to decrease going down a group. All right, so let's go ahead and look at our first example. Okay, and our first example, let's go ahead and find everybody on the periodic table. So we have lithium, fluorine, sodium, and carbon. So let's find them. All right, so there's lithium, fluorine, sodium right here, and carbon. Okay, so there we are. All right, so lithium, carbon, and fluorine are all in the same period. All right, and we know that electronegativity increases as we go across a period. And if we didn't know, we do know now that fluorine is the most electronegative element. Okay, so that's the most electronegative you can get on the periodic table. All right, so if we rank these guys from lowest electronegativity to highest electronegativity, then we're going to rank them as lithium. Okay, out of these, just the ones in the second period, lithium, carbon, and fluorine. Okay, so this is most, and lithium so far is least. But look at sodium. So sodium is in the same group, all right, and we would expect that the electronegativity for sodium would be even lower. Okay, and so we're going to put sodium here as the very lowest electronegativity. Okay, and then lithium and carbon are in between. All right, so why don't you try the next one? So pause it and give the next one a try, and then we'll go through it. Okay, so you ready? So let's go ahead and look at aluminum, chlorine, phosphorus, and magnesium. Okay, so I'm going to find them, and I'm going to circle them. So here's aluminum, all right, chlorine, phosphorus, and magnesium. All right, what do you notice right away? Right, they're in the same period, okay? So basically we can just write them down in order that they appear on the periodic table. So magnesium is going to be the lowest, and then aluminum, phosphorus, and chlorine. Okay, so out of this group, chlorine would be the highest electronegativity out of this group. Now, incidentally, I didn't write it up here, but if we were to do the same thing for electron affinity, we would get the same trends. Okay, so basically the lowest electron affinity would also be magnesium. The highest electron affinity would be chlorine. The big difference here is that the electron affinity for chlorine is higher, or more energy released than the amount released if we gave an extra electron to fluorine. Okay, now that is an exception. So remember that chlorine is the highest electron affinity of any element, and fluorine is the highest electronegativity. Okay, so that's where the two trends differ. Fluorine is not as interested in getting an extra electron as chlorine. All right?